Today, we're going to add transparency and refraction to our water shader. Let's go. Alright, so last week we added surface ripples to our water and made the surface look a lot more detailed and realistic. But the main thing missing now is transparency. So we need to add transparency and also refraction to our water so that you can see through the surface to what's underneath. And obviously water is going to act like a lens and bend the light, so we need to add some refraction to get that effect. Okay, so let's take a look at our shader, and we're going to add transparency and refraction. The first thing that we need to do is change some settings on our root node here. So I'm going to select our root node and come over here to the settings panel. Right now it says that our blend mode is set to opaque. So obviously that's the first thing that we need to change. So we're going to change our blend mode from opaque to translucent. That means our surface is something that light can pass through and we can see what's going on the other side. So we're going to set shading our blend mode to translucent, but that's not the only thing that we need to change. Later on down the road, we may do some things with the with what the water looks like underneath, and so we're going to set it to two-sided. And we're not doing ray tracing right now, so we're just going to go ahead and turn off cast ray trace shadows. Then we'll come down here to our translucency section, and we need to change the lighting mode. We're going to change this from volumetric non-directional. We're going to set it to surface translucency volume. And then the last thing that we're going to do, and I'll get to this in a little while, we're going to set our refraction method to pixel normal offset. Oh, and then one thing that I forgot, we need to change our screen space reflections. This isn't strictly required, but it will make things look a lot nicer if we turn on screen space reflections. If you want to create this effect a little bit more cheaply, you can turn this off, but we're going to turn this on just so that we get reflections of objects like those rocks that are around our water. Okay, now with those changes made, one thing that you'll notice right away is that we have this new opacity input port on our main root node. And we can use that opacity to control how opaque or transparent our water is. So let's switch over and take a look. And you can see that even with all of those changes we just made, there aren't any differences. We set the water up to be transparent, but we actually haven't made it transparent yet. So if I hold down 1 and click, I can add a new constant value here, and I can plug this into opacity. Now I can use this value to hard code how transparent or opaque it is. Since we're dealing with opacity, if we want it to be 100% opaque or not see-through at all, I can set this value to 1, and now you can see it looks exactly the same. And if we set this opacity value to 0 and hit save, now we have a water surface that's 100% transparent, and it's basically invisible for all intents and purposes, right? Okay, but if we set it to something like 0.5, now we can see that our water is partially transparent. Now, this isn't very realistic because we need to control how this opacity works. Now, in the case of water and a lot of other objects, actually, they use something called a Fresnel term to determine what parts of the water are going to be transparent and what parts are going to be opaque. And the way this works is when you're looking straight down at the water's surface like this, you can see into it, sometimes all the way down to the bottom, depending on how deep it is. And we'll get into depth in another tutorial, but you can see straight down into the water when you're looking down. But when you're looking out across the water, you can see the surface or the reflections on the water, but you can't actually see in. And in order to achieve that kind of effect, we're going to use a Fresnel node. And what this does is it creates a different color depending on the angle that you're looking at things. So if I'm looking parallel to the surface, I'm going to get one value. And if I'm looking perpendicular to the surface, I'll get another value. So just temporarily, we're going to set our opacity to 0. And we're going to set our Fresnel as our color. So this is going to color our water according to what our Fresnel node is creating. So let's go ahead and save this. And we just want to get an idea for what this Fresnel node is doing. So let's take a look. So now you can see if I'm looking down, I have this kind of a dark gray value. But if I'm looking out across the surface, I get a white color. So you can see out here, our values are white. And looking straight down, our values are kind of a darker value. We can see this better if I set this mode to unlit. So you can see my Fresnel value out there is kind of white, and then looking down, it's kind of that dark gray value. Okay, so what we can see here is we have a couple of inputs to Fresnel. We have the base reflect fraction in, and this is how much light is reflected by the surface, 0.04 or 4%. And this is pretty much typical for all surfaces, so we can just leave that one as it is. Then we have an input here for normal, and we've calculated our normals here in our previous video. So here's the bit that generates our Gerstner waves, and here's the part that creates the surface ripples that we did last week. By the way, if you haven't seen last week's tutorial, I'll put a link to it right up here. And be sure to go back and do that one first, because if you haven't created the Gerstner waves or the surface ripples yet, you're going to need those to follow along. All right, so using our Gerstner waves and our surface ripples, we've created the normal of our surface, which comes out of this blend angle corrected normals node. Now we can pass this in directly, but we actually need to tone it down a little bit first. So I'm going to multiply this surface normal. We're actually going to tone it down quite a bit. I'm going to multiply it by 0.05, and then I'm going to pass that into the normal input of our Fresnel. And then the other thing that we're going to do is flip around our Fresnel, because we're actually getting the opposite of what we want right now. And so I'm going to use a 1- node to invert our Fresnel, and we'll take a look. And now you can see when I'm looking straight down, I get these dark values, and then when I'm looking out there, I get the lighter values. All right, so now we are ready to use this Fresnel value for our opacity. So I'll go ahead and delete this constant value that we created for our opacity, and I'm going to plug in this Fresnel value instead. I'll delete it here where it's passing into our base color, and we're going to make this control our opacity instead. Let me just move over our root node, and we'll move these nodes. All right, there we go. Okay, so our normals are getting toned down. We're multiplying them by 0.05. Then we're passing that into our Fresnel term, which is generating our mask that is dark when we're looking straight down, and it gets bright when we're looking out across our waves. Okay, so let's save this, and we'll take a look at our result. Yeah, now you can see when I'm looking straight down into my water, I'm getting some nice transparency, but then when I'm looking out across the water, you can see the reflections on the surface of the water instead of being able to see down into the water. That's a much better result than what we were getting before when we just had a hard-coded value for our opacity. So I'll set this up again. If we just give our opacity a value of 0.5, this makes the whole thing uniformly transparent, which is not what we want. What we want is for our surface to look opaque when I'm looking out across it, and transparent when I'm looking straight down into it. And that's what we get when we do it this way. All right, the last thing that we need to do is create some refraction. And Unreal makes it very easy to add refraction to our shader. We just have an input here called Refraction, and it's set to pixel normal offset. And what this means is I can give it a refraction value, and it's going to use the normals that I've already created here to control the direction of that refraction. So I can just hold down the 1 key here and click to create a constant parameter. And then I can wire this in to my refraction. Now a value of 1 means no refraction, so I'm not going to get any light bending as it passes in. Let's take a look at our scene here, and I'll explain what I'm talking about. So right now, when I'm looking straight down into my water, the waves and the ripples on the surface are moving all around, but what I see under the surface is completely still. In other words, the surface of the water is not acting as a lens to bend the light. And this is actually not very realistic because in reality, because the surface is moving around, the light coming into it is going to get bent. And what I should be seeing is these rocks and other objects underneath the water should be moving around a little bit because the light is getting bent and distorted. And so that's what's happening with refraction. If I set my refraction to 1, that means that the light is passing straight through and not getting bent. And what I actually need to do is set this to a value of 0.5, which is the index of refraction for water. This is the amount that light gets bent when light passes out of air and into water. So with that value set, I can hit save and come back here. And now you can see that the normals on the surface of the water are acting like a lens, like I said, and distorting the water. So depending on how the normal is moving around, that distortion is happening. And we get a lot more realistic looking surface. And Unreal makes this really easy to create this refraction, because all we have to do is set that setting here on our refraction value to pixel normal offset, and then just set our index of refraction to 0.75, and we're all set. And our surface bends the light and distorts what's happening underneath it to make a very realistic looking water surface. Now there are some more things that we can add here. Right now, we don't have any concept of depth for our water, and so we can just see all the way down to the bottom. And that's what we're going to talk about next week. So I'm going to show you how to calculate depth for the water and introduce some color based on how deep the water is. All right, now let's switch over to Unity, and I'll show you how to do the same thing there with transparency and refraction. All right, here we are in Unity, and we're going to pick up right where we left off last week. We have our shader here that is doing our Gerstner waves and also the surface ripples that we added in last week's tutorial. But like I said just a minute ago, we don't have any transparency or refraction happening in our water, so that's what we're going to add today. So let's take a look at our shader and go ahead and get started. So here is the Gerstner waves portion of our shader, and then we're also doing the UV transforms for our ripples here and passing those into our vertex shader. And then in our pixel shader, we're doing our surface ripples calculation. But we don't yet have any transparency. Let's just go ahead and move all of these things over a little bit and give ourselves some space. And then we're going to take a look at our master stack. So I'm going to select our fragment shader here, come over here to graph settings, and we need to change some things. The first thing that we need to do is make our water transparent. So I'm going to open up our surface objects, our surface options, and here is our surface type. And this is what we need to change. Right now it's set to opaque, and I can drop this down and pick transparent. There we go. And then the next thing that we can take a look at down here is a setting called refraction model. And if I set this to planar, it's going to give me a bunch of extra options down here at the bottom that I can use for creating refraction. And I've done that in a previous video where I talked about how to create a glass surface. But we're not going to do that today. We're not going to use the built-in Unity refraction model. We're actually going to use something different because it's going to give us a little bit more flexibility to control the way that our transparency works. So when we set our surface type to transparent, now we can use this alpha value here to control the transparency of our water. So just like we did on Unreal, this value is just like the opacity value in Unreal. And if I set this to 0 and hit save, now you can see our water is 100% transparent. We can still see reflections on the surface, but we don't actually have any lighting contributions from the water itself. And if we set our alpha value to something like 0.5, now you can see that our water is partially transparent. So what we need to do is add a Fresnel node to control this alpha value. So I'm just going to come in here and add a Fresnel effect node. And let's just plug this directly into our alpha and see what happens. So now what you should see is when I look directly down into the water, I'm going to be getting a transparent value. But when I look across the surface of the water, I'm going to get an opaque value. So out there it's opaque, and then looking straight down, it's transparent. However, what I'm going to do is instead of using this alpha value, I'm just going to set the alpha to 0. And what we're going to do is use this node called HD Scene Color. And what this does is this gives us the value of the pixels that are underneath the water. So for example, if I just plug this directly into the base color of water, whoops, I use HD Scene Depth. We need HD Scene Color. And I'm going to hit this exposure checkbox and just pass this directly into our base color. Right. So now the surface color of the water is whatever is behind it. And this HD Scene Color has some really interesting properties. This UV input are the screen coordinates that we're using to look up this value. What's happening is we're rendering the screen into an off-screen buffer and then sampling it like a texture again to apply it to our shader. And these are the screen coordinates that we're using to sample that value. And then this is the level of detail or the MIP level that we're sampling. So if I want to make this value blurrier, I can say I want to sample MIP level 4. You can see that I'm getting these really blurry results for what's under the water. It's starting to look like milk instead of water. Because what we're doing is taking the screen, before we render the water, we take the rest of the screen, put that into a texture, and then when we render the water, we sample what's in that off-screen texture and apply it. And here we're just sampling like a lower MIP level of that texture. So this HD Scene Color node is really powerful. And so what we can do is we can blend between our HD Scene Color node and the color of the water. So I'm using this kind of dark blue color here. So I'm just going to go ahead and copy that, and I'll add a color node, and we'll paste our watercolor here. And now what we can do is blend between our scene color and our surface color based on this Fresnel effect. So we're going to add a lerp node, and I'm going to plug my scene color in here, my watercolor here, and my Fresnel color here. So now, on steep angles where I'm looking out across the water, I'm going to get this watercolor. Where I'm looking down into the water, I'm going to get this HD Scene Color, and I'm getting that blend using our Fresnel effect node here. So I'll go ahead and save this. Great, so now when I'm looking directly down into the water, I'm seeing the transparent portion, and when I'm looking out across the water, I'm seeing the opaque, that blue color that we added. Okay, there are a couple of more things that we need to add. First of all, I want to control my Fresnel effect with the normal from the water, because right now it's just using this world space normal. And we actually computed a much nicer normal here with our surface ripples. So I can use that. But in order to use it, I need to tone it down first. So I'm going to grab this value, and just like we did in Unreal, I'm going to multiply this by 0.05 just to reduce the amount of normal strength by quite a bit. 0.05. I'm just multiplying that down a lot. And now you notice that the Fresnel node needs this normal to be in world space. So I need to transform my normal. I'm going to add a transform node. And we'll set it from tangent space to world space. And our type is a normal. So now I can wire this normal into our Fresnel effect node. And that will control... Yeah, there you go. You can see how it's kind of distorting based on those ripples or those surface ripples that we created. So that is the Fresnel effect that we need. And then the other thing that we can do is we can add refraction here as well. And the way that refraction works here is we actually need to distort these screen coordinates that we're getting. So just to show you what's happening, I have this node called screen position. And this gives me a 0 to 1 range for every pixel on the screen. And it's what I'm getting by default here for this HD scene color node. So if I plug this screen position in here, I'll get basically nothing, or exactly the same thing that I would have gotten had I just left it as the default like this. So what I can do is distort or offset these screen position coordinates to simulate the effect of refraction. So right now, I'm not doing any refraction, and my results look like this. Actually, I've got this set to blur, so I'm going to set this to 0 blur, just so it'll be nice and sharp and we can see what's going on. Right, so now I'm not getting any refraction at all. But if I use my surface normals to offset the screen coordinates before I look up my HD scene color, I can get the effect of refraction. So what I need to do is take my screen position node here and add to it these surface ripples here. All right, so now if I pass this in to my HD scene color, so you can see that I'm taking my screen position and offsetting it using the values coming out of my surface ripples. All right, so when I save this and take a look, now you can see that the HD scene color is getting distorted by the coordinates that I'm using to look up my HD scene color are getting distorted by the surface ripples, and I'm getting pretty convincing looking refraction from my water. And I can control the strength of the refraction by this value right here, 0.05, this multiply. I can control how much refraction is happening. All right, so we've got our really nice transparency and refraction happening. Now, there's one more thing that I want to show you. I mentioned before that using HD scene color gave us more control. And I want to show you what we can do with that control. So here's my Fresnel effect, here's my watercolor, and here is the color of my scene underneath the water. Now, one thing that's interesting about the way that water refraction works is that wavelengths of light are bent different amounts depending on the light. So a blue wavelength of light will be bent differently than a red wavelength of light. And what that creates is called chromatic aberration. You can see it in a prism, where a prism will split the wavelengths of light into the rainbow. You'll get white going in, and coming out you get a nice rainbow. Well, water has that same effect. And using this HD scene color node, we can simulate that same thing. So let's go ahead and do that. What I can do here is copy these nodes. And what I'm going to do is, for each of the wavelengths of light, red, green, and blue, I'm going to offset them a different amount. So we'll use this top one here as red. We'll offset that at 0.05. We'll use this one as green. We're going to offset it at 0.04. And then finally, we'll create one for blue. And we're going to offset it at 0.03. So what we're doing is toning down the normal map slightly, different amounts for each of these different samples that we're doing. And now we'll take this value here. Actually, I think what I can do to just do this really easily is I'll just wire each of these into a combine node. See how this value is getting... Actually, I don't think that's going to work. I need to take the red channel here. So in order to isolate the red channel, I'm just going to add a swizzle node and have an X here. And then for the green channel, I'll just type a Y here. And for the blue channel, I'm going to use a Z there. Okay, so now this one, I'm just using the red channel, just the green channel on this one, and just the blue channel on this one. So I'll wire in our X, our Y, and our Z. So now we're building up this refracted color from each of these channels, and each of them is offset a slightly different amount. So I combine those together, and then I take that new color that I just created, and instead of going from this HD scene color, I'm wiring in the values that I created from all three of them combined. I hope that makes sense. And then we'll save this, and let's take a look at our result. Okay, now this is kind of subtle. I hope you can see it. If I look down here, what you can see is that there's this fringing effect on the edges. It's kind of pulling apart the color, and we get kind of a rainbowy effect where you can see kind of red and yellow and blue on the fringes of what's happening. So we're able to imitate the effect of light being scattered as it passes through our water surface. Because we're given that extra freedom of using this HD scene color node, we're able to control things a little bit more carefully. We can also control, as I said before, the amount of blur. So if I set my LOD value here to 2, and then we hit save, we get a really cool result where our water is refracting and splitting the light wavelengths and also blurring the amount. Now, what we really want to do is control that blur value and control the color of the water based on the depth. And we don't have depth yet, so that's what we're going to do next week. Be sure to come back next week and we'll add in depth to our water effect. But as for now, we just have our nice lighting, and it looks pretty cool. And we've got our refraction and our transparency, and we're creating a pretty nice looking water shader. All right, so next week we're going to talk about adding depth into our water. Be sure to come back for that, and in the meantime, have a great week.